Hello everyone, Sir Jules here and I welcome you all back to my YouTube channel. For today's video, we will be continuing with our organic chemistry lecture series. Now, for our previous topics, we've been discussing about linear electron configuration, the 1s2, 2s2, 2p6, orbitals, blocks, and electrons. Energy levels as well. But what does all of these things or topics mean? Now, that will be the focus of our discussion for today's lesson. And our main topic will be about the rationalization of electron configuration. Now, what do I mean by rationalization is that I'll be explaining to you as to what does all of those concepts and topics mean on a quantum scale level, which means that it's like taking a closer look to the atom, more like on a quantum scale on how does this look like, what does the S block, PDF blocks look like, its orbitals, and especially how the electrons are placed as well. Now, let's get started with this session. As I've been using this analogy constantly throughout our topics, I don't know if you still remember, but I've mentioned before that how we look at an atom, it looks like this solar system picture, wherein the center is our nucleus, and then going outwards, these orbits where all these planets are revolving around represents different, correct, energy levels. So as you go farther throughout into the space from the sun, the energy level increases. So let's just take, for example, the orbit of Mercury is the first energy level. For Venus, it's a second. For Earth, it's a third energy level, fourth, so on and so forth. But we have mentioned S blocks, its orbitals, the electrons. How does it look like when we take a closer look at it? Now, using the same analogy of this model, take for example, this is the energy level, right? The orbits. And as we know, based on the diagram that I've shown in the previous topics, the 1s2, only the S block contains the first energy level. Meanwhile, on the second energy level, we now have the S and the P block. But what does this S and P block means? Okay, so to shortly discuss what's that all about, let's have a closer look. I'll just try to erase some numbers here. Alright, so if we'll take a closer look at the atom, let me get my pen on red ink. Oh no, just keeps on zooming out. So let's have it here on the, I'll just put it here. Oh, why does it zooms out? It will zoom out again. Gosh. Um, but yeah, guess I'll have to do it this way then. So let's just take, for example, the second orbit of Venus. This will be on a second energy level. Now, as I've discussed that only S block and P blocks are contained within the second energy level. That's why the 2S and 2P. Now, think of it that these blocks are regions in space wherein we can possibly find an electron, where all these electrons are residing, thus their address, on a ground state of an atom. Okay? So let's just take, for example, the S block. Its specific region of space where it possibly occupies is, let's just say, it's around right here. So that's the S block. Now, the P block, let's say, it's around on the other end. So that's a P block. So what does this means? For the S block, we can have a maximum of 2 electrons, which means that around this area or around this region of space, we can possibly find these 2 electrons situated on this orbital. So that's just it. And since the P block can house a maximum of 6 electrons, which means that we can have 3 orbitals because each orbital can contain 2 electrons. So maybe right around here, we'll just divide this into 3 then. So around this area in space, we can possibly find an electron residing under the p block. So that's the block that it resides. So let's just say there are 6 electrons. So we can possibly find 1, 2, 3, 4, 5, and 6 electrons in this area specifically. That's for the p block and for the s block. Now, why do I keep on saying that we can possibly find an electron? It's because we have this certain concept or principle in physics. It's called the Heisenberg's uncertainty principle, which states that we can only tell that we might possibly find an electron around this area or in this region of space because we are uncertain. We are only certain up to a certain degree, but not that certain as to 100% that we can find an electron in these areas. But based on theoretical physics, then we can just say that, yeah, we can find an electron in these areas. So that's just basically it. Okay? So that's how it would look like. And just to tell you, this is on a two-dimensional picture. How about the reality of the quantum mechanical model of the atom lies on a three-dimensional. So I'll just give you an overview of how this different SPDF blocks looks like in a quantum scale. All right, S block. Since the S block can contain only 2 electrons at maximum, then possibly we can find an electron right here, 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 or anywhere in this space, but only 2 of them. So that's the S block. As just a simplified. Only around that area we can possibly find the electron moving around. Now, how about for P block? The P block can house maximum of 6 electrons. Thus, they have these 3 orbitals, which namely we have the px, py, and pz. And within these regions of space, we can possibly find the electron, an electron, right? So that's it. Same here and also right here. That's how this would look like in a quantum scale. Now moving forward with the D block, which can have up to 5 orbitals. Now it just keeps on getting complicated, but this is how it would look like. For the D block, we can only house 2 electrons, right, for each orbital. So around this area in space, we can possibly find electrons moving around. We can only say up to a certain degree. Not 100%. We will never be 100% sure that electrons can be found here, but only around these 4 areas, there can be 2 electrons moving around in this space. Okay, so we have 1, 2, 3, 4, and the 5th orbital for the D block. Now, moving forward with the F block. This is how it would look like. It's like a more complicated since the F block contains houses a maximum of 14 electrons with 7 orbitals. So each orbital, so we have 1, 2, 3, 4, 5, 6. So around this area, all 6 of them, we can possibly find 2 electrons jumping from this space to another. So yeah, basically that's it. And for the F2, F3, F4, F5, F6, and F7, the 7th orbital, we can only say, guess, maybe it would be a fit word to use. We can only guess that up to a certain percentage, we can say that electrons can be found here in this region of space, around these blocks, around these orbitals rather. Okay, so that's how it would look like on a two-dimensional scale. Now, to make things more complicated, but we don't want to complicate it more further because this is just a fundamental concepts that we want to discuss as we progress further with organic chemistry, and we're not focusing here on physics or about the quantum physics instead. So there's just an overview, just on the shallow part of how it is defined or how it looks like on a deeper level of analysis. Now, for the three-dimensional, how it will look like. It looks like this. And can you guess what type of atom or element is this? This, the one on the center, this is our nucleus. Because nucleus is always the center. And then this, let me use my pen. These areas around here that you can see, this resembles the orbits in the solar system, right? And this is the third one, the larger one. So these are the energy levels. Now, would you be glad if, or shocked rather, if you'll find out that this is just a hydrogen atom? What is hydrogen? Hydrogen is the first element with atomic number of 1. I'm sorry. With only one electron. But here's the thing. Electrons keep on moving around these areas of space. That's why we can only say maybe at the maximum possibility that around these three energy levels, the electrons keeps on jumping from this space to another. But that's only one electron, but we are trying to plot as to where are the possible places this single electron can be. So that's how complicated it would look like on a quantum scale. But on a three-dimensional model is how it would look like in reality. Okay? So I hope you learned something from this video regarding a rationalization, explaining what does all those electron configuration is all about and how it would look like on a quantum scale. And thank you so much for watching, and I'll see you in the next one.